Yes, student. What do you see? Yes, sun in the sky. We can see the sun is approximately on my head. Okay, it is not exactly, but we can say it is on my head. Okay, student. So why I am showing this? Because today we are going to learn one of the chapter of EVS 1, that is fifth chapter of EVS 1, temperature, fifth standard. Okay, students, are you ready to learn about temperature? Okay. Yes, student, have you observed the sun? Yes, because of the sun rays, we can see the surface of the earth get heated. Okay, and because of the surface of the earth get heated, the closest layer of air to the surface get heated. It means air on the surface get heated due to the heated surface. Okay, okay, student. For this purpose or to understand this, we are going to do an experiment. Okay, students, are you ready? So today we are going to learn one of the chapters of EVS 1 fifth standard, that is temperature. Okay, students. So here I have done one of the experiment in the night so that you can understand how does the sun rays falls on the surface of the earth. Okay, the beams of sun rays falls on the earth and how does it affects on the surface of the earth as well as the closest layer of the earth. Okay, student, have you understood? So here, as I told you, earth is spherical and due to its spherical shapes, the sun rays do not fall equally on each surface. Okay, somewhere we find perpendicular and somewhere we find slant and somewhere we find very extremely slant sun rays on the earth. And now today we are going to study the effects of the sun rays that falls on the surface. Okay, students, are you ready? So let's have, or first of all we will do an experiment, then we will learn about the effects of the sun rays. Okay, student, have you understood? Very good. So without wasting time, let's get started. Students, today we are going to study about temperature. First of all, we will do an experiment. To do an experiment, we will be requiring a white cardboard and a torch. Students, right now I don't have torch, but I am using the torch of mobile. Okay, first of all we have to keep the cardboard in a 90-degree. It means right angle. It should be in right angle. Okay, and then we have to focus on it with torch. Okay, and then we have to see how does the light or sun rays concentrate on the cardboard. We have to suppose the light or the torch is as the sun rays or the beams of sun. Okay, students, so without wasting time, let's get started. See, student, here I have kept a cardboard and it is in a 90-degree. It means in right angle. Okay, students, for better understanding, I will switch off the light so you can understand the concentration of lights on the cardboard. Okay, students, I have switched off light. Now I will on the torch. See, student, here I have kept the mobile torch at a certain distance. Okay, you can see the light is concentrated in a perpendicular direction. We know that the sun rays that falls on the earth's surface that are perpendicular, but the earth doesn't receive the sun rays in perpendicular direction everywhere. You know that sun rays fall on the equatorial area that are in perpendicular direction. But as we move towards North Pole and South Pole, the sun rays fall that are not perpendicular, but they are slant. Okay, students? Now see, in a particular distance I have kept the mobile, so you can see how much area the earth is acquiring. Okay, see, can you see? You can see the all light is concentrated together. Okay, now students, I will draw a circle around the illuminated area. See student, I have drawn a circle roughly where you can see the light is concentrated together. Okay, so this much area is concentrated when we have kept the cardboard in a right angle. Okay, in 90 degree. Okay student, now we will change the position of card. We will keep the cardboard in 120 degree in a obtuse angle. Yes student, what do you mean by obtuse angle? Obtuse angle means more than 90 degree and less than 180 degree. Okay students, so I will change the position of cardboard and then we will see how much area it will be occupying. Students, see now, I have changed the position of cardboard. Okay, I have kept the cardboard in 120 degree. Okay, but the mobile torch is at the same distance. Okay, so you can see the light has concentrated, but the light has occupied a larger area than the previous one. Let's see. First of all, I will draw the circle, then we will understand how much area it has occupied. Okay. Students, see, I have drawn the circle. Okay, let's compare the both the circles now. Which one is the bigger one? When we have kept in the 120 degree, how much area does it have acquired? And then how much area acquired when we have kept the cardboard in 90 degree? Yes student, have you understood this much? Now we will compare both the circles. Okay, see students, this circle which we have drawn on the 120 degree cardboard. Okay, and now we will see this much. This is the smaller one. This circle we have drawn on 90 degree cardboard. Okay, and this one is on 120 degree. Okay, which one is the bigger? So the circle which is drawn on the 120 degree occupied larger light, okay, than the 90 degree cardboard. Okay, what does it mean? Students, let's try to understand now. What does it mean? Sun rays coming towards the earth travel in straight line. However, as the earth is spherical in shape, these are not perpendicular to all the parts of the earth's surface. In some parts, they are perpendicular, whereas in other parts, they are slanting. Let us see what effect it has on the earth. The perpendicular rays occupy less area. The part where the rays occupy lesser area receives bright sunshine and greater heat. Hence, the surface there gets heated more and the air becomes hotter. The slant rays occupy a larger area. In this area, sunlight appears less bright and there is less heat. Hence, the surface there gets less heated and air too is less hot. Okay, student, have you understood? Where the surface of the earth gets heated quickly as well as the air, and where the surface of the earth gets heated less as well as the air also. Okay, student, have you understood? So here we have done an experiment and we have understood that where there are the sun rays are in perpendicular direction, there the surface as well as the air get heated quickly, and where there are slant sun rays, there the surface of the earth as well as the air get heated slowly and lesser than the previous one. Okay, student, have you understood? Okay, very good. Students, now we are going to study the figure number 5.2 given on the page number 24. Okay, student, here we are going to understand the earth's shape and the distribution of sun rays. Okay, student, so here we can see earth is given. As we know, the shape of the earth is spherical. Okay, and see this side sun is given. Okay, suppose this is the sun and the sun rays are falling on the surface of the earth. Okay, student, then let's see here sun rays are given in a different way, A, B, C. The sun rays A is falling on the center of the earth. Okay, here we can see this is the equatorial. Okay, this is Tropic of Cancer. Okay, and this is Tropic of Capricorn. Okay, students. Okay, so here at the center of the surface the sun rays are falling. Here we can see the sun rays are perpendicular, exact perpendicular we can say. Okay, then now second we will see the second sun rays beam we see fall on the surface of the earth. This beam is somewhat slant, it is not perpendicular as sun rays or the beam of A. Okay, but it is slant one, you can see slant one. See, this is slant line, you know, slant, sleeping line, slant line, and a vertical line or standing line. This is standing line, it means it is in perpendicular. This is slant one. Okay, student, now let's see the C sun beam. Okay, here the sun rays falls, this is very extremely slant one. The sun rays C fall on the surface of the earth is very slant one or extremely slant we can say. This is perpendicular, this is slant, and this is extremely slant. Okay, student, the sun rays falls on the surface of the earth where it is perpendicular. Here we will see this part of the surface of the earth receives more light. So here this area receives a lot of sun rays or sunlight, and due to this it is very hot area. Okay, this area is called as torrid zone. Okay, and this is the largest equator on the surface. So, and it is 0 degree. What it is? It is 0 degree. Okay, student, have you understood? So this area is called as 0 degree area or equatorial area. It is the hottest area or the region on the surface of the earth. Okay, student, now here we see the sun rays are very slant one. Okay, the sun rays are very slant one. So here the intensity of sun rays goes on decreasing as we go upward from the equator. Okay, as we go upward it will more and more slant one, and due to this it will receive less light or less heat from the sun. So this Tropic of Cancer is at 23 degree 30 minute north. Okay, in the same way 23 degree 30 minute, okay, it is south. Understood? So 0 to 23 degree 30 minute north, this region is called as torrid zone. Which zone? Torrid zone. Okay, student. Okay, and then as we are going up and up, the sun rays become slant. So here we see the temperature of the earth is moderate one. What? Moderate one. Okay, student. The sun rays C shows here with extremely slant sun rays. Okay, so here the heat received by the earth is very less, so this area receives less light, and due to that it is cool area, it is completely cold area, we can say. Okay, this is called as frigid area. What? Frigid area. Okay, this area is moderate one, this is moderate, this is torrid. Okay, so this zone, that is 0 degree to 23 degree 30 minute north, is called as torrid zone. Then 23 degree 30 minute north to 66 degree 30 minute north. Okay, this is moderate region, and above that, that is completely frigid region. Okay, frigid region. Okay, or snow capped area, we can say, that is the north pole. Okay, it is the north pole. Okay, student, and this is 90 degree. What? This is 90 degree. Okay, student, have you understood now how the sun rays are distributed? And due to distribution of the sun rays or uneven distribution of sun rays, we see the divisions of temperature are different one. 0 degree to 23 degree 30 minutes north is known as torrid zone, or the hottest zone on the earth's surface. And then 23 degree 30 minutes north to 66 degree 30 minute north is called as moderate region. Here we see the temperature is moderate. And 66 degree 30 minutes north to 90 degree is called as frigid zone. Okay, student, so in this way on the earth there are three zones of temperature: torrid zone, moderate zone, and frigid zone. Okay, student, have you understood this one now? Due to the surface, due to the shape of earth, as well as the distribution of sun rays is uneven, so we see here the distribution of temperature is also different one. Okay, students, have you understood? Very good. Students, one more important thing I would like to tell you. As we have seen the distribution of the sun rays on the northern hemisphere, the same thing is here on the southern hemisphere. Okay, the same you will see here. Here Tropic of Capricorn 23 degree 30 minutes south, then here 66 degree 30 minute south here. Okay, and here the south pole, that is 90 degree. So 0 degree to 23 degree 30 minutes south is torrid zone. 23 degree 30 minutes south to 66 degree 30 minutes south is temperate zone or moderate zone, and 66 degree 30 minutes south to 90 degrees south is frigid zone. Okay, student, have you understood now the frigid zone, temperate zone, and the torrid zone? Okay, students, have you understood? Very good. Students, here we have seen the latitude is playing very important role in distribution of the temperature. or sun rays we can say. Okay, so latitude is the main factor. There are other factors also which influences the distribution of temperature. Okay students, however their effects are limited to particular region only. These factors are nearness to sea, continentality, height above the mean sea level, and physical setup, or a region are factors that lead to diversity in the climate of different regions. Other than these factors like cloud cover, winds, vegetation, urbanization, industrialization, etc. also influences the local climate. Okay student, have you understood now here how the latitude, we have learned about latitude in the first chapter. Okay student, how the latitude affects on the distribution of the temperature. Students, have you understood the distribution of the temperature? Yes, from equator to the north pole and south pole. On the equatorial area we see temperature is high, but as we move towards the north pole and the south pole, the temperature goes on decreasing. Yes student, okay, so the area near to the equator is called as torrid zone, then next to it temperate zone, and next to it the snow capped area or frigid area. Okay student, have you understood this distribution of temperature? Yes student. So today we have studied the distribution of temperature on the earth. Okay students, have you understood this much? Very good. Students, if you have liked this video, like it, share it to your friends, subscribe it, and press the bell icon so that you will get current notification of new videos. Thank you. Be connected.